Hi everyone, this is Pradosh Kumar, faculty from Biomedical Department. In this session, I am going to discuss about inverting and non-inverting amplifier. The inverting and non-inverting amplifier are considered to be basic applications of operational amplifier. So in this session, we will discuss about inverting and non-inverting amplifier. First, inverting amplifier. So first, what is an inverting amplifier? Inverting amplifier means when an input is given, the output you will be getting from this circuit will be a inverted value of the given input. That is, the output will be 180-degree phase shift. That is 180-degree phase shift with the input. So the output voltage will be Vin into minus Rf by R1. That will be the output voltage we will be getting from a inverting operation amplifier. So now we will see the derivation of an inverting amplifier. First, if you see this circuit, first we need to do is applying KCL, that is Kirchhoff's current law at the inverting terminal. So this is the second pin. We have connected the inverting terminal, and third pin is the non-inverting, which is grounded. Voltage input we are giving to the inverting terminal. So there we have to apply Kirchhoff's current law. So what will be the equation? Current I1 is equal to input voltage V in minus V B, V in minus VB divided by R1. So what is this VB? Here VB is nothing but the value that is being given to the non-inverting terminal. That is, non-inverting terminal is connected to ground. So what happened based on virtual ground concept? This point of this node also, that is this node means voltage VB also considered to be 0 volt based on virtual ground concept. So what happened means Vn minus Vb by R1, Vb is equal to 0. So substituting that, we will be getting our equation input current I1 equal to Vin by R1. So next we need to write the equation for the feedback path. So feedback current through RF, that is IF equal to feedback current IF equal to VB minus V out, V naught, that is V naught divided by RF. So what is our VB? We know VB is 0. So 0 minus V out by RF. So our equation will become minus V out by RF. Since input bias current is 0, we can equate these two equations, that is I1 equal to IF. So when your left hand side you are equating means we can equate the right hand side, that is I1 equal to IF is nothing but in I1 we have seen V in by R1 and IF is equal to minus V out by RF. So equating that, we will be able to find the equation of output voltage. So what is the output voltage for us? Minus RF by R1 into V in. So we have got our output voltage. From this we can identify what is the gain. So we know output voltage is nothing but gain into voltage input. Since our output voltage is equal to gain into voltage input, gain is nothing but the multiplication factor of the input voltage, that is minus Rf by R1. That is nothing but the gain. So the negative sign indicates the phase inversion. So from the negative side we can understand that the phase will be inverted. So when you are giving one input means the output will be the multiplication factor of the amplification, that is gain, multiplied by the input voltage. So this is a waveform of the input and output of an inverting amplifier. See here we have given the input as a sine wave with 1 volt, that is a 2 volt peak to peak, right? So 2 volt peak to peak. So here what we have given means we are assuming our gain to be 2. So from this, when your input is 2 means multiplication, we will be getting 2 into 2 4. So in this case what happened, our output will be a minus 2 to plus 2, that is 4 volt peak to peak. Input is 2 volt peak to peak, our output we have got 4 volt peak to peak based on the gain used. The gain used is 2. So we have got our output as plus 2 to minus 2, that is 4 volt. So this is from this circuit, from this output we can understand that when our input voltage is given means the output will be the phase shift, 180-degree phase shift output will be getting, that is we can call as out of phase. See, it is inverted. So whatever input is given, it is exactly inverted form we have got the output, and also the value will be amplified based on the gain. So this is the concept about the inverting amplifier. So next we will discuss about the non-inverting amplifier. So what is a non-inverting amplifier means, when the input is given, our output will be only amplified value of the input, but there will not be any inversion of the input. That is, there will not be any phase shift occurring for the given input. So this is a non-inverting amplifier, where that is we are giving our input to the non-inverting terminal, that is plus. So we are calling it as non-inverting amplifier. And the negative, as usual, we are giving the negative feedback in the circuit. So output voltage will be input voltage multiplied by gain will be 1 plus Rf by R1. So next we will discuss how we are getting the derivation of a non-inverting amplifier. So voltage divider at the inverting node. So at the inverting node means second pin minus, we can see there voltage divider we have to substitute. So as per voltage divider theorem, what is the equation for the ground resistance divided by the sum of the resistance multiplied by supply voltage. What is the supply voltage for this one means output voltage. For the negative terminal, if you are considering supply voltage means V0 will act as a supply voltage. So R1 ground resistance by sum of the resistance R1 plus RF into V0, that is V out. So we know as per the virtual short, this virtual ground principle, for an ideal op-amp, input of this circuit is that VB, whatever will be the VB, similar thing can be considered for the VA. So we will be getting the equation as, so based on that we will be getting the input voltage V in as, solving the above equation, R1 by R1 plus RF into V out. So next, what will be the output voltage V out equal to, solving the previous equation, will be getting V in into 1 plus RF by R1, and so we will be getting our final gain equation as, gain is 1 plus RF by R1, because we know output voltage equal to gain into voltage input. So apart from input voltage, the remaining thing is considered to be gain. So what is the gain voltage gain? 1 plus RF by R1. So next we'll see the waveform of the input and output for a non-inverting amplifier. So when we are giving the input as a sine wave, so what will be our output? The output will be an amplified value of the input, but there will not be any phase shift that occur in the circuit, since it is a non-inverting amplifier. So that is non-inverting amplifier, the given input will be amplified, that's it, but there will not be any phase shift, that is the output will be in phase with the given input. That is the concept for the non-inverting amplifier. So in this session we have discussed two types of amplifier, that is inverting amplifier and non-inverting amplifier. So inverting amplifier means amplify and we will be getting the inverted output, and non-inverting amplifier, the output will not be inverted of the given input. Okay, the output will be in phase with the input. So thanks for listening to this session. Thank you.